In this video, we're going to look at how to add or subtract and multiply and divide fractions, and also rational expressions. Rational expressions, they look like fractions, but they have variables in there, for example, like this one here. So first, let's look at how to add fractions. And the steps are going to be the same for adding rational expressions. So first of all, we have to make sure they have matching denominators. But in this case, 3 and 6, they don't match. So we have to find a number such that 3 and 6 both can go in there. Apparently, 3 can go into 6 and 6 can go into 6. So we're going to take 6, which is also called the least common denominator. And so we are going to turn the both denominators to 6. And for the first denominator, 3, in order to turn that into 6, we need to multiply it by 2. So for the first fraction, we're going to multiply the denominator by 2, and correspondingly, we multiply the numerator by 2. This way, we will keep the equivalence of the fractions. And for the second fraction, because the denominator is already 6, so we don't have to do anything. If you want, you can multiply by 1, but it doesn't really change the denominator. So now we have 2 times 2, 4, 3 times 2, 6. So we turn the first fraction 2/3 to 4/6 plus the second fraction. Now, since they have the same denominator 6, so we just add the numerators. And again, when we add fractions, we don't add the new denominators, we only add the numerators. So we have 4/6 plus 1/6. Together we have 5/6. And when we add rational expressions, the steps are going to be the same. So first step, we're still going to look for the LCD. But since this time we have not only numbers but also variables, we have to consider both separately. So we need to find something that contains both the number 5 and a 2, which is 10. We know 5 goes into 10 and 2 goes into 10. But we also need to find some variables that contain x, so we need to have x. We also have a variable that contains y, so we have the LCD 10xy. Now, if you have trouble seeing the LCD this way, you can do what we did before, use factoring. So for example, we can break down 5 and x as 5 times x. And we break down 2xy as 2, and I'm going to create a new column for 2 since we want to line up the same number and the same variable, because 2 does not match 5, so I'm going to create a new column for that. But x, the next factor is x, which matches the x we already have. And then y, we don't have a column y, so let's create a new column. So now we bring down for LCD or LCM, we'll bring down one number or letter from each column. So the first column we bring down a 5, second column we bring down an x, the third column we bring down a 2, and fourth column we bring down y. So now when we multiply 5 and 2, that gives us 10, and x we bring down and y we bring down. So as you can see, it's the same answer as what we got here. LCD 10xy. So now we are going to turn 5x to 10xy. Notice that in order to turn 5 to 10, we need to multiply by 2. And x, we already have x in here, but we also need to get y, but we don't have y, so we're going to multiply 2y. Now, as you can see, 5 times 2 will give us 10. This x will give us the x needed, and this y will give us the y needed. So similarly, when we look at 2xy and we want to turn that to 10xy, first of all, let's turn 2 to 10 by multiplying it by 5. And this x will be the x we needed, and this y will give us the y we needed. So as you can see, when we multiply 2xy times 5, 2 times 5 will give us 10, and this x and y will give us the xy we needed. So now we're going to go back to make the changes. So as you can see, the first denominator 5x, we need to multiply it by 2y. And correspondingly, we must multiply the numerator by the same thing. And for the second denominator, 2xy, we're going to multiply it by 5. And for the numerator, we also multiply by 5. So for each fraction, first of all, since they don't have the same denominator, we have to turn it into the common denominator, 10xy. And after, how do we do that? We determine what we need to multiply. And make sure for each fraction, you look at the denominator first, decide what you need to multiply, and make a copy for the numerator. The same thing here. And after we multiply, the denominators will be the same. 5 times 2 is 10, x times y is xy. 2 times 5 is 10, and xy bring down. Now, since they have a matching denominator, so all we need to do is to add the numerators together. So we got 4y plus 5. And notice 4y and the 5, they are not like terms. We won't be able to combine them. So we're going to just leave the answer as 4y plus 5 over 10xy. And notice when we compare these two problems, even though we have variables in the second problem, and the steps are exactly the same. And we find out LCD, we multiply what we need to turn the both new denominators to the same denominator. And then we keep the denominator, whether it's 6 or 10xy, and then we only add the numerators. All right, now let's look at a division problem. And first of all, recall the rule of division is division of fractions is keep, change, flip. So first we're going to keep the first fraction 2/3 and change division to multiplication and flip 1/6 to 6/1. Now we're going to use the rule of multiplying fractions, which is straight across and reduce. So first of all, we're going to reduce the numbers. Notice that 3 and 6, they both have 3 in common. So I'm going to divide both of them by 3. Now 6 divided by 3 is 2. 3 divided by 3 is 1. So now let's multiply straight across. 2 times 2 is 4. And the bottom, this section, we're going to give us 4/1 because 1 times 1 is 1. But 4 divided by 1 is also 4. So we should simplify that to 4. The other way to do this is you can multiply straight across, and you get 2 times 6, 12. 3 times 1 is 3, and 12 divided by 3 is 4. This also works. So for smaller numbers, if you multiply, then you're not going to get a huge number, and so it's not too bad to do this way. But of course, when you have bigger numbers, it's always better to reduce the numbers to smaller numbers and then multiply. In this problem, we have 2 fractions. We call them rational expressions, but they look like fractions. They just have variables in there. And this is also similar to the previous example we talked about division of fractions. So the rule doesn't change even though we have variables. So we're still going to apply the same rule, keep, change, and flip. So we keep the first rational expression. If you want to call it a fraction, that's not a big problem. So we have 7a squared over 9b, and change division to multiplication, and flip 21x to the bottom and 12y to the top. So now we're going to have to multiply them. So remember, the rule to multiply in fractions is multiply straight across and reduce. So usually we would like to, especially when we have big numbers, we would like to reduce the numbers of the variables as much as possible and then multiply straight across. So we're going to do that here. So first, let's look at the numbers. 7, 9. So when we reduce numbers, we have to pick a number from the top and a number from the bottom to see if they have anything in common. So 7, 9, they don't have anything in common. 7 and 21, they do have 7 in common. So let's divide both of these numbers by 7. So 7 divided by 7 is 1. 21 divided by 7 is 3. And now let's look at 12 and 9, or you can look at 12 and 3. So either way, it doesn't matter. So 12 and 3, they both have 3 in common. So we can divide 12 by 3 to get 4, and 3 divided by 3 to get 1. Now 4 and 9, they don't have anything in common. So we have to stop. So that's all the numbers. So you can see what's left will be, so 7 is reduced to 1, 12 is reduced to 4, and the bottom 9 is still there, and 21 is reduced down to a 3 and then down to a 1. So we write down 1. So next, let's try to reduce the variables. And notice in this case, here the top has variable a squared, which means 2 copies of a, but the bottom doesn't really have any a's. And so we cannot reduce any a's. And y, the top also has a y, but the bottom doesn't have any y's. And again, the top doesn't have any b's or x's to reduce. So it looks like for the variables, there's nothing we can reduce. Okay, but if I change this y to a x, they match, then we will be able to reduce them. But since we have different variables here, one of them is y, the other is x, we have to keep them there. So final answer will be 1 times 4 is 4, 9 times 1 is 9, and a squared y over bx, none of these variables can be reduced. So just quickly summarize the rules. When we add fractions or subtract, we have to make sure they have matching denominator. But for multiplication, they don't have to have the matching denominators. As you can see here, they have different denominators, but we can multiply them straight across. And for division, we use the rule keep, change, flip.